Assalamualaikum and hello everyone. Welcome to the video where we discuss past year question for the year of 2022-2023. In this video, we will discuss question 6 involving chapter 7 ionic equilibria. Question A. Benzoic acid C6H5COOH is a weak monoprotic acid with a dissociation constant of 3.5 exponent negative 8. The equation for ionization is as follows: C6H5COH plus H2O in equilibrium with H3O plus and C6H5COO minus. Okay, question 1 Roman, calculate the concentration of all the species in 0.1 molar C6H5COOH. So they asked to for the all of the species lah. Okay, so we go back to the question. Okay, the question did give us the hint that this is our weak acid. Why here? Weak monoprotic acid. Okay, and then it already give us the dissociation constant. Dissociation constant is actually, this one is our K. K apa? Ka. A stands for our acid lah. So even if the question does not give you the statement it is weak, you may know it if the question give you the Ka, or luckily this question did give us the equation, this one. Okay, so when we're talking about calculate the concentration of the species, okay, for example, if I have my HCl, HCl is a strong acid, they're fully dissociated. That's why we will have the full arrow plus Cl minus. For example, if HCl here is 0.1 molar, hence H plus 0.1, Cl minus pun 0.1 molar lah, all of the species. This is for the case of strong acid. Okay, but this case, this is a weak acid. So it dissociate partially, but we do not know how many does it dissociate. So yeah, itu we have to do our ice table lah to know the concentration of all the species here. Kalau kita buat K, K ni means in our equilibrium. Okay, so when we're doing ice table, we have to use this equation. Luckily, this question did give us the equation. Okay, so I'm just going to go through a bit. Okay, since this is our acid, here is our acid. Acid don't need H plus. So once it don't need H plus, that's why it becomes C6H5COO minus. Okay. So if this is our acid, H2O will become our base. So if it base, it will accept. So that's why it will form H3O plus lah. Okay. It's just that for this equation, if the equation is given to you, if it's not in phase, so no problem lah. Tapi sebenarnya easier for you to write down the phase because later on you're gonna use it. Because we have to be selective for the species when we're writing down the K. Okay. So in this case, remember, okay, if you can't, just write down at the end here. H2O, only H2O will be liquid. Any other solution will be aqueous. Okay. For example here, the shortcut to it, if you have ionic solution, ionic charge, this one is actually aqueous. Okay. H2O liquid. Then our benzoic acid will become aqueous. Remember, only H2O, water je liquid. Yang lain semua aqueous. Okay, why do I have to write down? Later on lah, when using my, when I want to write down my K. So again, here concentration of all the species, given that K means that we have to find their concentration and equilibrium. Then we have to use the ice table by using this equation. So ice table stands for the initial change equilibrium. Okay, for the ice table, you have to include the unit lah. If not, you have to write down the unit one by one here, for example. Okay, so based on the information given, we only have the concentration of our benzoic acid to be 0.1. So I'm just going to write down 0.1 lah. Okay, so how about the changes? The changes here will become minus X because this is our reactant. If it's on our left side, it will be reactant automatically. Okay, so and then H2O is a liquid. So again, based on K ni sama macam Kc, only for gas and aqueous. For chapter 7, mostly kita akan jumpa aqueous lah. Okay, so H2O ni, I'm just gonna write down dash yang ini. Okay, next is H3O plus. Okay, H3O plus is our product. Initially, our product, if it's not given in the question, we're gonna take it as 0. for both of the species. So the change here is X juga. We do not know. We have to find it out. But this case it will become plus. Okay. Plus minus ni just to show that the concentration here decrease while the concentration here increase. Okay. Negatif ni bukan masuk concentration to negative tak. Dia berkurang. How many? Okay. So for the equilibrium when we add up this initial and change. So this is our ice table lah. Okay, back to the question. The question wants to find the concentration of the species in 0.1 molar. Maksudnya dia nak yang ni. In equilibrium. Okay, why? Because we have our K, the equilibrium lah. Okay, so how do we find out the value of X? That's why they bagi the value of Ka. Okay, but then how do we find out the value of Ka? So from this equation, I'm going to write down what is my Ka. Yang concentration of product divided by concentration of reactant. Again, A only for this case gas or aqueous. This chapter mostly aqueous. So when you write down the Ka, remember for our liquid, H2O is our liquid. Liquid is not included. Okay, so the value is given in the question 3.8 exponent negative 8. Okay, so this one, what is the value that we have to substitute? Again, K means that the reaction is in equilibrium. So we have to substitute the value in equilibrium. Once you have substitute the value, then you can calculate lah, find your X. Okay, why? Because we have to find the concentration here. Okay, but then only for chapter 7, if the value of Ka ni, or chapter 7 ni ada Ka, ada Kb, ada Ksp. If the value is less than or smaller than exponent negative 5, then there are some rules lah, ataupun there are some exception to it. Okay, contoh kalau exponent negative 6, diterima. Exponent negative 5, terima. Exponent negative 4, it's not included lah. Okay, must be smaller than or equal to. Okay, so what are the rules or what are the exception? We will take our denominator. Okay, we will ignore the X. We can only take the value lah. Only for case of chapter 7, Ka, Kb, Ksp, this one. Okay, kita guna yang ni lah. So, what does it mean? So, for our denominator ni, we're gonna just take 0.1. For example, if I have 0.2 minus 2x, maknanya kita akan ignore yang 2x ni. We're just gonna take the value. Okay, so must be smaller than or equal to negative 8. Okay, so I'm just gonna, okay, maknanya sekarang ni, yang ni bukan 0.1 minus x lah, become 0.1 only. So then here, the calculation is quite straightforward. Okay, for example, if you don't want to do the assumption ataupun you're a bit confused, tak nak assume, no problem. You can also, for example, from this one, then you can expand the equation, then you will get it in quadratic expression, then you can factorize pun boleh. So, apa ni? In quadratic expression yang ni lah. Then you can factorize pun boleh juga. Tapi this one is quite straightforward sebenarnya. Much more straightforward. Because this one, then you multiply, and you become equal to x square. Then you just square root the information here. So for example here will become, when we multiply, here will become 3.5 exponent negative 9 equal to x square. Then you can find the value of x. Okay. So the value of x will be 5.92 exponent negative 5. Okay, so there's the unit to the x, because remember, here x ni, unit dia is actually concentration. Okay, so ada unit lah sini. Okay, back to the question. The question asks for concentration of all the species. Okay, again, when we're writing down the ice table, species yang kita ada, the concentration only these 3. Again, why H2O liquid is not considered dalam K? Because the concentration remain constant. So that's why lah. So kita include. Okay. So then we can substitute straight away concentration of species in equilibrium. For the H3O plus and C6H5COO minus, quite straightforward sebab the value is X. And X kita dapat dari sini. So this is the concentration for these two species. You still have to write it down. Ni baru tahu value value of X. Question nak concentration species kan. So here is for the product. Okay, so H2O is not included. Then we have to include juga. We have to find the concentration of our benzoic acid. So 0.1 minus X. Minus X yang inilah. Okay. Once you substitute it, you will get the value to be 0.1 molar. Sama je dengan initial. Okay, why? Because our X the value is very small, exponent -5 kan. So sebab tu lah. No problem, memang itu pun jawapan dia. Even though you see there's no difference, it's actually because, again, weak acid ni dissociate partially. Very partially, we do not, very small. So ni dissociate, exponent -5, very small lah. So that's why you will get this answer. Okay, again, because for the question 1 Roman ni, or for chapter 7 ni, if our weak acid, dia akan bagi Ka ataupun Kb. It could be also Kb lah. But this case, yang this one, ni macam simple, straightforward, sebab dia go back to chapter 6, sama sahaja. The difference is that, this one, kita boleh assume if Ka, Kb or Ksp less than or equal to exponent -5, then we can assume. Which yang ni lagi simplify kan, lagi shortcut kan jalan kerja kita. But yang lain-lain quite straightforward, the same as our chapter 6. So that is for question 1 Roman. Question 2 Roman, calculate the pH of this solution. So pH, what is the formula of pH? pH is negative log H plus or H3O plus. H plus or H3O plus is the same lah. Okay, kenapa sama? Dia sebenarnya, contohnya, means ada HCl, become H plus plus Cl minus. This is, for example, if I have the equation of our acid ni dissociate by itself. So H plus dengan Cl minus lah. Tapi kalau HCl plus H2O, pun sama juga, acid will donate the H. So here become become Cl minus plus H3O plus. So if H plus and H3O plus is the same lah. Kalau H plus OH minus tu dah lain lah. But then H plus dengan O is the same. Kalau H plus is not equal to OH minus. Okay, kalau yang ni sama sahaja. So this question asks for negative log H plus, but when we look based on the equation, tak ada pun H plus. Sebab tu kita tengok pH is the same, negative log H3O plus. H3O plus we got here. And then again, apa-apa must be the in equilibrium dia. And the equilibrium we also have calculated from question 1 Roman, this one. Then we can substitute the value, this one, straight away into this formula. Then you will get your pH to be 4.23. Okay. So for the question A ni, dia quite straightforward, senang sikit. Cumanya bila dia kata weak acid, we have to do the ice table first, then we can answer lah. Can remember H plus, H3O plus is the same. Kalau dia minta concentration OH minus, tu tak sama lah. That will be very different. Tu boleh jadi POH kita. Okay, so that is for question A. Question B, magnesium hydroxide, MgOH2, is used in the treatment of occasional constipation in children and adults. Question 1 Roman, calculate the molar solubility of MgOH2 in water if the solubility product is 5.61 exponent -12. Okay, so molar solubility, so it means that the question asks to find our molar solubility, we denote it as S. So what is S? Given that the solubility product, SP ni apa? Solubility product usually we call it as SP. In this case, this is KSP. For chapter 7, we have Ka, Kb. Okay, A stands for our acid, B stands for our base. Okay, but usually for the question, it will give us, this is Ka, this is Kb. But for the KSP, usually it mentioned it is solubility product. So you have to know that is your KSP. Okay, so information what we have is our KSP. Okay, same as our Ka, same as our Kb. Our KSP don't have any unit. Okay, solubility here, since here mention pasal molar solubility, so the same as molarity lah. The unit will be molar or mole per liter. Okay, so in this case, when we're talking about solubility, we want to know how many solid dissolve in water to form our solution kan. Okay, so what happens is that we will dissolve the MgOH in water. So this is based on the information itself lah. Usually kalau dia tak bagi tahu pun dissolve in water, we're gonna assume it as in water. Okay, so to write down or to find the S given from KSP, then we have to write down the equation lah. Okay, so what we have our MgOH, 2. So for example, so we have our MgOH2. Okay, we dissolve in water, we will form MgOH2 solution. Okay, but then for our equation, or for 7.3, this is back to 7.3 solubility equilibria. So actually our solution here, it is a saturated solution, and MgOH2 here is actually an aqueous. Remember that H2O is the only liquid. Other than that, we're going to assume it as aqueous. Okay, so this one, for how to write down the KSP, usually we don't write down the solid to be MgOH to aqueous. No, we do not write this down. Actually, for this one, we dissociate it further. It will become, this one will become Mg2 plus and OH minus. Again, this is aqueous, so that's why all of this, our ion, the charge will be aqueous as well lah. So here, if it's in equilibrium, the arrow. Okay, how do I know it is in equilibrium? Here, K. K is given kan, so we know that it is in equilibrium. Our arrow must be this one lah. So we have to make sure it will be our product is Mg2 plus and OH minus. So make sure the equation is balanced, then you know that you'll get 2OH minus. Okay, so right now again, KSP given is 5.61 exponent negative 12. So how do I know the S? Okay, so usually when we're talking about K, we're going to use I stable, right? So I stable. This case you need the molar, molar, molar. Okay, this case I stable, again only for gas and aqueous, solid is not included. So there's none of this. Initial product, we don't have any value, so 0. Change here will become plus. If you refer back to chapter 6, we write down plus x ni plus 2x kan. So this equilibrium will become x, here become 2x. Okay, for 7.3, or when we're talking about solubility, okay, we're going to use not x, our unknown, it will become here s and 2s. Okay, so that's why for our KSP, regarding our solubility, we don't do I stable. Actually, based on the equation, we can know the equilibrium. Okay, we can know the equilibrium straight away, which depends on the change. The change is depends on the balance equation. So here, my change will be, here will become S, here will become 2S. Okay, so the question here asks for the solubility. Which solubility? My S and my 2S here lah. Or specifically, ni, S sahaja. Okay, so how do I know, ataupun how do I find out the S? Okay, first, I have to write down KSP is equal to what? Again, KSP back to product over reactant. Again, must be gas or aqueous. Okay, so for this equation, our KSP will be Mg2 plus multiplied by OH minus to the power of 2, because here we have 2 at the front of the species OH minus. Okay, next, then we can substitute lah. KSP is this one. Mg2 plus is S. OH minus is 2S. But don't forget, here we have to the power of 2. Again, don't forget, here, y is 2S because based on our balance equation. Here, square ni kenapa? Again, based on our equation as well lah. So, what happened here is that, here will become 4S cube. Okay, so this is S. Again, 2S ni square, so maksudnya 2 square S square. So ni ada S. So S cube to the power of 2 will be 4. Okay, back, the question asks for the solubility itself. We have to find what is S. Hence, you will get your S to be 1.12 exponent negative 4. Again, so molar solubility, molar, the unit is molar lah, M, capital M. Or if you want to write down mole per liter pun also can. Okay, so for this question, here it mentioned about solubility product. When we talk about soluble, so it means that the solid dissolve in water to form our aqueous solution. But for our aqueous solution tu, bukan kita buat yang MgOH ni. Okay, we dissolve it further or we dissociate it further, Mg2 plus and OH minus. Then we have to make sure the equation is balanced. Okay, so this one, the same as Ka, Kb, we have to write product over reactant. Our reactant is solid, so that's why it is not included, only for the product. This one, you don't have to do the I stable, even though it's given K. Ni je yang K tak perlu buat I stable. Why? Because the initial 0. There's no information for initial. We don't want to include anything since it is a solid. For this one, equilibrium is same as the changes itself. Okay, so that is for question 1 Roman. Question 2 Roman, explain the effect of solubility of MgOH2 after addition of Mg and O3 to solution. Okay, so first what we're gonna write is Going to write down what is the equation for MgOH2, which we have done from the previous calculation step. And the previous question mentioned that this is dissolved in water. But this case, for question 2, explain the effect of solubility after addition of MgNO3 to solution. So this is a solution. Again, this is an aqueous. So based on this one, I'm going to write the how does it dissociate? Again, the same as this one. But this is our solution. So for solution, it will become N aqueous. Okay, remember, solution only H2O will be liquid. Other than that will be aqueous. Okay, this one is not in equilibrium solution kita, so we're just gonna use our arrow here. So it's the same one. It will become Mg2 plus as well as NO3 minus. Okay, make sure the equation is balanced. Then here I will get 2 NO3. So here you mentioned that if explain the effect of solubility. So what happens is that to explain it, first you have to mention. So this one, for based on this equation, these two equation, we can see that there are common ion. Common ion means the same lah. Which one is the same ion? So Mg2 plus is the common ion. So what does it mean by Mg2 plus is the common ion? The concentration of Mg2 plus will increase. Okay, because we have this one a common ion, so the concentration here will increase. So what happen if the concentration of Mg2 plus increase? Right now, this salt ataupun this solubility, the MgOH in water, it is in equilibrium. But what happened when we dissolve in MgNO3, our concentration here increase. So it is not in equilibrium anymore lah. Yang ni go back to Le Chatelier. So from here, actually equation kita mula-mula balance like a seesaw concentration kan. But right now, when the concentration of Mg2 plus increase, dia bukan jadi seesaw yang balance lah. What happen is that this one will increase. The concentration dia akan decrease. Concentration of Mg2 plus increase. So what happen is that our seesaw ataupun here seesaw kita tak balance. Dia akan jadi macam ni. Right? Why? Because this one increase. So how to make it balance? Yang ni kita kena to the left. We have to make sure it's to the left to make sure it balance again. Okay, tapi apa yang to the left, apa yang to the right? Again, di Chatelier tu, when we're talking about to the right or to the left, we're talking about equilibrium position. We have to mention the equilibrium position will shift to the left again because this one, when this increase, our seesaw is not balanced. Ni yang lagi besar. Ini sama je size dia. Okay, so to make it balance, it will shift to the left. So what does it mean by it shifting to the left? Maksud dia, our Mg2 plus and OH minus, we prefer to form the MgOH solid. Okay, so we have to write down the MgOH2 will form. More of our solid here will form. When more MgOH will form, yang ini, then we can explain the effect of solubility lah. Solubility adalah ketelarutan. If we have more of our solid, so it means that it is less soluble. Okay, so we have to mention that the solubility will decrease. Again, solubility larut. Kalau larut tu maksudnya kita lagi form solution kita lah. This one terbalik pula. MgOH. MgOH our solid yang banyak form. So solubility will decrease if there is common ion. Okay, so this is an example of a solution. So contohnya kalau dia dissolvekan in water, as you can see here. Okay. So here you mention in equilibrium because our saturated solution ada dia punya solid. So dia ada juga aqueous dia lah. Okay, but then what happen if it's in a common, if it is a solution where we have our common ion, for example, okay, kenapa solubility decrease? As we can see here, solid dia bukan je kat sini. This is not the only solid form. Atas ni pun ada solid. Okay, that's why we mention this one, solubility decrease. Dia kurang larut lah. This one solubility decrease, ni solubility increase. Kan? Solubility adalah ketelarutan our solid. Ketelarutan solid tu lah. Ketelarutan pepejal. Okay. That is all for the question 6 for PSPM 2022-23.